All right, let's try number 20 and 17.1. So, what do they want us to do?
Find a parameterization.
Okay. Find a parameterization or parameterize a line. What?
Perpendicular to that plane.
Perpendicular to the plane. Good.
That goes through that point.
A point. Perfect. Okay, so I need, first things first, what? What do you need to make a line? 2 dimensions, 3 dimensions, 17 dimensions, lines are all the same. What do you need?
Another point.
Okay, that would work. That would be inconvenient in this case. Right, you can make a line out of 2 points or a point and a slope, right? Okay, so let me find a slope. I need a slope that's what?
That's perpendicular to the plane.
Perpendicular to this plane. I already had a point, right? There's my point. Okay, so I better be able to make that other thing into a slope. Okay, so I need perpendicular through that. Had better make me a slope. How do you get that?
To the opposite slopes of that plane.
Do we need partials?
Don't negative reciprocize. You got an easier one. So what's a line, or what's a direction perpendicular to a plane? The gradient would work. Well,
Kind parallel.
yeah, the gradient would almost work here. We could make sense out of the gradient. What else? What's perpendicular to a plane? We have a name for that.
Tangent.
Multiply the normal vector.
Normal vector. Yeah, which I get, right? When I write the equation of a plane as 2 things multiplied together get 0. You guys remember that?
Yeah.
So if I fill my equation from z is 2x minus 3y plus 7, how do I want to fiddle this to see 2 things multiplied together to get 0? Yeah, I want to see the dot product, right? So let me move the variables to one side, leave the number on the other.
Sure.
Okay, so if I move the variables over, we got z, what?
Minus 2x plus 3y equals 7.
Minus 2x plus 3y is 7. Right, that was add 3y, subtract 2x. Okay, so once I'm here, what do I want a dot product with?
With 116, right?
No.
No, it's just U1, U2, U3.
Yeah, I just want some kind of this dotted with this equals number.
Would be
So
Z1
you guys-
negative, Z1 negative 2 equals 3.
1, negative 2, 3. Good. Dotted with
Anything.
z, x, y. Okay, that's not usually how I write vectors. Yeah.
Yeah.
Okay, so let me rearrange those. So we rewrite that as x, y, z. And what's your vector you're dotting with x, y, z?
Negative 2, 3, 1.
Negative 2, 3, 1. Good. Okay. So I remember, right, that there's this kind of general displacement vector, and I dot it with a normal vector to get my equation for a plane, right? Usually I have like x minus something, y minus something, and z minus something. Where's that stuff? Yeah, it's in the 7 on the other side. You guys see that? So I now know what the normal vector to that plane is. It's this guy. That's a normal vector there. Negative 2, 3, 1. My normal vector. So why was I doing this?
To find a line perpendicular.
Yeah, I want a line perpendicular. Here's a vector perpendicular, right?
Yeah.
So those are the slopes.
Yeah, so what I got is I got a plane, right, like this. There's my blue plane. Out of it, stick in my black normal vector. And now I don't know where the heck the point 116 is in relation to this picture, right? That might be way over here. But what do you do?
Find displacement.
Can you just plug in 116?
Yeah, just plug it in, man. So I want a line that starts at 116, right? So what do you call your line?
I don't know.
Something. Okay, Donald with the horrible vector names today. All right, so I'm calling my line Q for some reason.
Yes, I know.
And what's the variable?
T.
T, sure. Okay. Where's Q start?
116.
116. Okay, and then I want to add what?
The normal vector.
D dot
I want to add the normal vector, I think. -2, 3, 1. Right? Point plus slope
T.
times variable. Right? Really look at this and think, y is b m x, right? You guys see that? So what's going on here is I have an origin someplace in my picture. Like maybe, heck, I don't know, over here. So maybe here is 0, 0, 0. I want to go out to the point 116, right? That's out along a vector, 116. And then I want to go up and down along the normal vector for the plane, right? So what I'm going to do is I'm going to take that normal vector, I'm going to move it over here. That's still perpendicular wherever it passes through that plane, right? Okay, see that? And so we're going to go out to the green point and then up and down some multiple of that black thing. That'll give me a line that looks like this.
So our normal vector becomes our slope.
Yeah, perfect. I wanted something that was perpendicular to this, so I took the normal vector of it. I know that's perpendicular, and then I'm just going to use that as my slope. Does that kind of follow? Cool. Jacob. When I asked him if there were any questions.
I'm so sorry.
No, you're good. Just ask it again. It was good.
Is Q of T our answer?
Yeah, absolutely. They asked me for a parameterization, so I gave them a equation with t's as variables and vectors as outputs.
Okay.
Right, so when they're asking for a parameterization, what they're asking for is a function, like in this case q, that takes r and turns it into three-dimensional vectors. So here's such a thing, and it has the property specified because it starts at that point and has that normal vector as a slope. Any more?